another interruption. This was a bad time to try to make videos. So this is notes about torque. Okay, so we're going over sort of the basics of torque. And I will get my wheel back. So when we're talking about torque, we're going to be interrupted every 5 seconds apparently. So when we're talking about torque, we need to once again think about angles just like we did for work. Okay? So when we're talking about torque, we're trying to make something rotate. Okay? Now there are two variables at play here and infinite number of interruptions. Okay, so there's two variables at play. One is the radius, which is going from the center up to where I actually am applying the force. So it's like straight from here, the center where it's actually rotating about, up to wherever I'm applying the force. If I apply the force here, then I have a much shorter radius. If I apply the force here, I have a much bigger radius. Okay? So that direction here is like straight up in this example. Now, which way should I apply my force in order to make this rotate? If my radius is coming straight up, I need to actually apply my force either left or right, okay? And that will cause it to rotate. Now, if I apply my force down in the same direction, right, as my radius, because my radius is from here to here, if I apply my force in the same direction, nothing happens. It doesn't rotate, right? If I apply it this way, up, also nothing happens, right? So it really needs to be perpendicular, right? If I look at my radius as being from here to here, right, so I'm looking at this point here, I need to apply up or down, okay? So when we're talking about how many times I can get interrupted.
All remaining students who are going home, you may now be released.
So
All remaining students who are going home, you may be dismissed. Thank you.
when we're talking about torque, we need to worry about our radius, force, and the angle between these two vectors, okay? So I have r, f, sine theta. In this case, theta is usually measured in degrees. You could use radians, but usually it's measured in degrees. Now, once again, if we're counting the amount that this is spinning, right? So if I'm going from here, I'm doing half circle and then a full circle, that would be 2 pi. We use radians for counting like how far I've traveled. But in this case, you could use degrees. Okay, so I have RF sine theta, and you'll notice the sine of 90 degrees is 1. Okay, so we get our maximum torque when these two things are perpendicular to each other. Now, if they are perpendicular to each other, you can go ahead and just drop this like we did for work, right? When we knew that our push was in the same direction as the distance, we could just go ahead and drop this. Once again, for torque, if I have R and F, and I know that they're perpendicular to each other, I can go ahead and drop the sine theta. I don't need to write it. Now, if they are not perpendicular to each other, I definitely need to go ahead and write that. Okay?